What is the real-world range of the Kia EV3? My name is Bastiaan and welcome to Electric on Wheels. I think a lot of people have been waiting for this car and well, it is here, so it is time for a range test. And of course the version that is standing here is the most expensive version, so that means GT Plus line with the bigger battery pack, which also means a WLTP range of 563 kilometers. If you take a less expensive version with the 17-inch wheels instead of the 19 that this one has, then you can get a WLTP range of more than 600 kilometers. But again, this one has a WLTP range of 563 kilometers. Will I be able to do that? No, I will not, because it is winter. It is around 4 degrees Celsius when I do my test. There is no wind, so that is good. But again, 4 degrees Celsius. And there is no heat pump available on the Kia EV3 here in the Netherlands. So that WLTP range, no, I will not reach that. I will not reach that. How will I do the test then? I will do one test at 100 kilometers per hour. And during that test, I also calculate how much energy I can get out of the battery. I will do one consumption run at 130 kilometers per hour and one at 90 kilometers per hour to simulate those mixed driving conditions. How much energy I can get out of the battery, the consumption at those tests, and boom, I can calculate the range. The car is charging up and then let's go. I am currently doing my 100 kilometers per hour test. The car is in highway driving assist, so I don't have to do anything. I don't even have to change lane. It cannot be easier than this. What car is that with the red blinker? That is not a European car, because then it would have a orange blinker. Oh well, I didn't see it. Anyway, 100 kilometers per hour test. The car has used 10% state of charge, and on that 10% I have driven around 41 to 42 kilometers. So the range, it seems like right now, is, well, 410 to 420 kilometers. But I'm not sure if that will be the end result, because Korean cars are known for not having a linear state of charge scale. So 1% at the top is more than 1% at the bottom. That is because, well, how the state of charge is calculated. Because of that, I am driving this car from 75% to 25%. So I have 25% left on each side. And therefore I hope to cancel it out. But therefore I also do not know if that 410 kilometers will be the end result or not. The average consumption is 18.6, it's currently 18.5, but around 18.5 kilowatt hours per 100 kilometers, which is not the best result, to be honest. Our e-Niro does it better. I'm pretty sure it would have been better than this. And that is because, well, that car has a heat pump and this one does not. And, well, this car has bigger tires than our Kia e-Niro. But anyway, keep on cruising. Another update at 33%. Alrighty, the car has used 33% state of charge, and on that 33% I have driven around 142 kilometers. So that means that the range, it seems like right now, is still 425 kilometers. Does that mean that the Koreans have learned and that the state of charge scale is now linear? It does look like it, to be honest. The consumption is also still the same. It is 18.5 kilowatt hours per 100 kilometers. Again, still not that great. But now first, the 90 test. Yeah, this looks a bit better. I am currently doing my 90 kilometers per hour test. As you can see, it is day now. It is a very nice winter day actually, but it is still around 4 degrees Celsius, so that is the same. But because the sun is shining, the climate control has to work a little bit less hard, and therefore the consumption is a bit better. It is currently hovering at around 16.5 kilowatt hours per 100 kilometers. Again, that is a lot better than the 18.7 that I had while I was doing my 100 kilometers per hour test. I have just turned around doing my 130 kilometers per hour test, and the average consumption is around 25 to 26 kilowatt hours per 100 kilometers, which is not great, but also not bad. What is great though is the way this Kia EV3 drives, because the stability at higher speeds, the quietness, and also the comfort is a massive step up if you compare it to, for example, the Kia Niro EV Really well done by Kia, really well done. I will keep on going for another, I don't know, 15 kilometers or so, and then you will get the result. Alright, the result of the range test. Keep in mind that during all my tests it was around 4 degrees Celsius and there was barely any wind. First of all, the 100 kilometers per hour test. I started the test with 73% state of charge and I finished it with 26, so that means I've used 47%. On that 47% I have driven 198.1 kilometers, so that means a range of 422 kilometers. The average consumption was 18.7 kilowatt hours per 100 kilometers. Taking all these numbers means I could get around 79 kilowatt hours out of the battery of usable capacity. So 422 kilometers, average consumption 18.7 kilowatt hours per 100 kilometers. I have to say, I'm a little bit disappointed in this result. I am a little bit disappointed, and that is because this car does not have a heat pump. A heat pump consumes less energy than a normal PTC heater. To keep this car nice and cozy at around 20.5 degrees Celsius, because that is the temperature I have set on the climate control, the car is pulling around 1 kilowatt to 1.6, 1.7 kilowatts. And that is around 500 watts to 1 kilowatt more than a heat pump would do. And therefore I did a little test. I did a consumption test, not a whole range test, but a consumption run without the climate control on. Do I say that right? Yes, the climate control was not on. And then the average consumption was 17.3 kilowatt hours per 100 kilometers. So 1.4 kilowatt hours per 100 kilometers less than with the climate control on. And it makes sense because that 1.4 kilowatts is around what the non-heat pump PTC heater is using. So yeah, why Kia, why don't you deliver a heat pump on the beefed up model? Is that a good word? On the most expensive model. I mean, this car costs almost 50,000 euros. You would expect a heat pump. And yes, I know, if you translate that amount of kilowatts that a PTC heater is using more into money, it's not a whole lot more, but still, I want the most efficient car. I just want the most efficient car. And the thing is, without the heat pump to heat up the car, so when I get into the car, the climate control is set on 20.5 degrees Celsius, and the car is heating up the cabin, it is pulling 4 to 5 kilowatts of power. 4 to 5 kilowatts for at least 5 minutes, 5 or 10 minutes, and then it slowly ramps down, and it is at around 1.5 kilowatts after around 20 minutes, 15 to 20 minutes. So that means in winter, if you don't have a heat pump, and you drive a lot of short trips, the consumption is really high. Too much, if you ask me. So yeah, I am disappointed in the winter consumption. And well, if you drive a lot of short trips, then well, the consumption is really high, above 20 kilowatt hours per 100 kilometers, trust me. But do I think you can reach the WLTP range of this particular car is 563 kilometers in spring summer? Yes, I think you can, if I'm honest. During my 90 test, the average consumption was 17.3 kilowatt hours per 100 kilometers. So that means a range of 456 kilometers. So yeah, 17.3 kilowatt hours per 100 kilometers. Subtract around a kilowatt hour of energy, because well, the heater is using that and air conditioning is not using that much. I mean, it's a heat pump, but in reverse, or a heat pump is a air conditioning in reverse. Whenever you get the drill. So then the average consumption would go to 16 kilowatt hours. In summer, the car is more efficient anyway. So yes, in spring, summer, I do think you can get the WLTP range with this car. You can in all Kias actually, so I do expect this as well. Then the consumption at 130 kilometers per hour, that one was 26.8 kilowatt hours per 100 kilometers. So that means a range of 294 kilometers, which is okay. 26.8, not great, not bad. That means in better weather, warmer weather, you can get more than 300 kilometers with this car while driving those speeds, and that is pretty good actually. So yeah, conclusion, Yes, I do think you can get the WLTP range in spring, summer with this car. In winter, the efficiency isn't great. And in winter, when doing a lot of short trips, it's not good. It's not good. All right, that was the video then. Thank you a lot for watching. Don't forget to like, comment and subscribe. And then as always, to be continued.